Hello everyone, this is Tariq L1 presenting the second lecture of SBM4104, the IT infrastructure. What we will cover today, we will go over the physical layer and the data link layer. If you have watched the previous lecture, we mentioned that the physical layer is layer number 1 inside the OSI model, and the data link layer, that's the layer number 2. We will go over each layer. We will discuss the type of data transmitted, circuits, analog data, digital transmission, the analog data, the analog transmission, what is MAC, what is the data link protocol, and we will finalize with the Ethernet standard, which is 802.3, and the final piece will be, I will show you how the network card look like and the 2960 switch from Cisco. Let's go over the physical layer and what that layer exactly, the function and the services of this layer. If anybody remember from last session, layer number 1, the main function is transmitting the data. So you actually sending the data from top, which is layer number 7, moving through layer per layer, adding headers or PDU, and then now the time it arrive at the physical layer. The physical layer right now need to send the data. However, what type of transmission I will send? For example, do you use wired or wireless? If wired, I'm gonna use some kind of transmitting. If wireless, I need to transmit it. And even within the wired transmission, what type of let's say technology using within the wired? Are you using the normal Ethernet? Are you using coaxial? Are you using fiber optic? What kind of cable are you actually using? Because based on the technology we use, we have to transmit the data based on that. If you are using wireless, we have plenty of technology under wireless. Which technology exactly you are using? And here is the issue for the physical layer. How to transmit the data into electrical signal, different type of electrical signals. So that layer focus on the physical or the hardware, and include that we have circuits. The circuits means either cables, that cable usually connected to either routers, switches, hubs, or you transmit it into wireless as well. We have different type of circuits. We have physical one, and that's the actual what you're using as a cable. So it's like a wired, whatever it is, but that's actually a physical one. We have logical circuits, which I believe if anybody still remember from, let me okay, I will use the red. Yep. If anybody still remember from, yep, that's good. So if you still remember from last time when I told you that about the multiplexing, this is the cable. I have a cable over here, and that cable, for example, 10 megabyte or 10 megahertz. So this is the what we do exactly as a logical breakdown. What we do exactly, we break this one into, it's one physical, one cable only. However, inside that, we break that down into multi-channels, and that one we call it logical circuits. So it's like actually one physical, break it down into multi logical, and that's the logical circuits channel. So how you transmit the data? We transmit the data usually either in terms of digital data, which is that's the one which he actually has a lot of advantage. We transmit the data in the term of 010101. When that's 1, that's flat, means 0. That's how it is. And this one has a lot of advantage over the analog. The analog usually it's like this, signal like that. You keep going like this. That's how it is, the signal, ups and downs, ups and downs, ups and downs. The phone or the telephone, that's to be considered as the normal phone. I mean, the landline phone. This one usually we use the analog, which is wave, sequence of wave. A lot of technology currently right now transmitted into digital, phone technology transmitted into digital. However, still the landline phone mostly using the analog. Sure, if you compare between both, the digital usually win. The analog transmission, that we use it in the radio as well, the AM and FM. However, to transmit between digital to analog or analog to digital, you need a modulator. What that modulator? The small device at home, when you call it modem, the one we call it modem. If you are home here, this is your home, and this is the phone line, for example, and this is your computer. The computer use 010101 like this. The phone use analog. So here is analog, here is digital. Which device exactly can convert between digital to analog, analog to digital? That's what we call it modem. And that modem actually is a modulator, but for us we just call it a modem. And as well, it work as some of devices work as code C or coder decoder. And this one, when we have a data or analog data, try to be sent over a digital transmission. And that's another story, because that's we need to quantization, which is away totally from your studies. The analog data, let's go over. This is the how to configure the circuits. If I have circuits, how to configure the circuits. I mentioned to you last time that's the point-to-point, which is you have device 1, you want to link to device 2, device 3, 1 or 2 want to device 3, device 3 want to go to device 1, device 3 want to go to device 4, device 1 I want to go to 4, 2 to go to 4, like that. If you want to go to device 1 to 1. Alright, is that good connection? By the way, that's the one we used inside the torrent. However, is that let's say professional, not professional? Is that a good one? It is a good one, but however, it's a good one under few devices. If you are using few devices only, that's a good one. However, when it comes to thousands or let's say hundreds or thousands or tens of thousands of devices, that's totally not practical and very expensive. So what we do exactly, we have another type of circuit, which is, this is the one-to-one. We have another type of circuits, which is, as you can see over here, the multi-point. What is the multi-point exactly? Very basic. If you have studied something called line bus or network topology, we have the line bus. The line bus is like something like a medium or cable, whatever you call it, and you have multi-devices connected to. This is device, that's a device, 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 device. Alright, how we share that, how do we share that medium? Well, here's the deal. One device can use that medium at a time. So what to do exactly? We have what we call it, we sense. The device sense the circuits or the channel. See that if someone using it through the electrical pulse, by the way. So if someone using that device will not send, will wait until the channel become clear, then I start send. However, even with that, still some collision happen, which is another story away from your study for now. So the multi-point and the point-to-point. Keep that in mind, please. When data transfer between two devices, you have something which the data flow. The data flow or the data transmission. In short and very easy way, the data can be transmitted into one way, and we call that simplex or simple. Half duplex, which can go either way but one at a time. So this one, yes, I can go this way or that way. However, one at the time. You can send this way, so the other one has to wait until finish and send. Yes, the transmission can two ways, but half duplex. Half duplex means, yes, you can transmit in two directions, but one at the time. The full duplex is not. The full duplex, as you can see over here, you can send the data this way and that way at the same time. No problem at all. Imagine that it's one lane, that one lane, and you one direction only. This is one lane, but you can drive two directions, in and out. This one, two lanes. Keep that in mind. The media which you're using, the media means the way you send the data. If I am here, I want to send the data to that device, or that device won't send me the data. How to send it? What we call it media. Media means the way between me, what media, what technology will carry the data I'm gonna use. In short, so we have two type of media. If you using cables, it become guided media. If you using wireless, that becomes unguided. Guided or unguided. So guided media, that's wired. It has to go through wires, cables, whatever the cables are. Different type of cables, but you actually, the cable can carry the data through guided, so you direct it. The wireless, we cannot. The wireless, it goes from here. This is, for example, this is the AP. The data goes this way and hits something and come back this way and then hit something like that. Which another study, when you study wireless, you will learn that. But with the unguided or wireless media, there is no exact direction for the data. One of the famous cable, which is actually the most used, by the way, currently in the market, what we call it, the twisted pair. The blue cable you see in Epic College, or you see in Victoria University, UNSW, wherever you study, you will find it over there. Those kind of cables, which is the blue one, sometimes you can see that the yellow one, sometimes different color, different combination. However, for you to understand for this unit only, that twisted pair of cables, as you can see here, the twisting, that one, we twisted the cable because of the electromagnetic field. What is that exactly? If you have any cable, wired cable, and you try to pass some kind of electricity inside, that one will create electromagnetic field automatically. And that's why we have in electricity, for example, because of that. So what to do exactly? If I put one cable like that and another cable like that, it will increase the electromagnetic wave. If I put another cable like that, it increase as well. It add to each other. To avoid that, what we tried to do, we twisted the cable, the pair of cable. Why is that? For example, I put that cable like that, the electromagnetic field become like this. You put the other cable like that, the electromagnetic field will go in the opposite direction like that, which will end up eliminating, not fully eliminating, but at least reducing the electromagnetic field around the cable. The electromagnetic field around the cable create interference. Interference means noise around the cable, and we don't want that. So as you can see here, we have in the twisted pair, we have 4 pairs. Each one has 2 cables, so the total is 8. Depends on the combination here. You may heard about some type of combination for those cables. Later on, when you connect similar devices, which you will hear about something called straight cable, non-straight, you will find something like that. You will see the combination of those cable decided which cable you will use. We have another one like that exactly, but we put in the top of these cables, as you see, we put foil aluminum cover. What is that exactly? Shielded twisted pair. What is that shielded twisted pair? As you see over here, I think most of you familiar with the foil paper. Something like the foil paper. Yes, we cover those ones with the foil paper. It come automatically already made. What is that? It reduce actually more the electromagnetic interference, and usually the shielded twisted a little bit expensive than the normal one, so you have to pay extra for that. Another cable which is you may familiar with that, the TV cable or the coaxial cable in our studies. The TV cable or the coaxial cable, as you can see here in the picture, you can see over here the inner conductor, and this is the one which carry all the connection and the electricity or the signal, the white piece and the shielded, and over here all those ones, the outer cylinder, the plastic one, the cover over here, then the second conductor, then the insulator. The insulator something like high intense rubber, like foam, high intense foam, to protect that one. So you actually putting plastic, then some kind of second conductor, then another insulator, and then or plastic, you can say that, to protect what? To protect this only. Yes, that's the one. Which one? Why we do that? At first to protect it from the environmental, from the water, from electricity, from anything around it. At the same time, we protect it against the electromagnetic signal as well. And this one less, as you can see, less prone to interference and more expensive, sure. However, it's much higher, can carry data more than that, more than the twisted pair. The fiber optic cable, which is the latest in the market currently and latest technology, and we have two different type of fiber optic. However, the fiber optic is, when it came to the market, it used to be very expensive. It's still expensive compared to the other ones, but year after year it's getting cheaper. The fiber optic is the latest one, and it used light inside. What we're using exactly? Light. We pass light through a fiber glass, light from here, and we have emitter, something like, imagine that is a flashlight. You passing flashlight from here, it goes over here and it's arrive here. That's how it is. That's how it is. But flashlight in term of 010101. Light means 1. Now no light means off. That one, that cable, you have the glass over here, as you can see, like if you can see over here, this is the glass, which we consider as micron, 5 to 50 micron. In short, to make it short, to get that, the piece or the part which carry the data inside the cable less than a single hair size. So check your hair, and that's the part. Sure, we need to protect that part, which is the glass part, the fiber glass part. How to protect that? We surround that glass by multi layers, which you can see here, couple layers over here, and this one we call the cladding. And as well, that's the cladding, some kind of intense compressed, you can say that plastic or fiber foam. In the good thing is, you can say it foam. That I'm sorry, the reflect the signal. That foam, which is some kind of protected materials. However, that protected materials which can reflect the light inside with some kind of type of fiberglass as well. That fiberglass can reflect the data inside. So if you send a data and the data inside here try to goes outside, even it goes outside, it will go back again. It will reflect somewhere and come back again, reflect somewhere and come back again, like that. So keep reflecting. Then we put at the outside This one, the protective jacket, which is some kind of compressed plastic or compressed foam or different materials. However, it's mostly some kind of plastic. The radio wave, which is involved mostly, if you want to send the data, you need to send the one which you're familiar with, the AM and the AFM radio. Include as well the cellular phone. We have different type of technology which you can use the radio wave. Many, by the way. The main concept of the radio, you need somewhere device which transmit the data in different direction, for example, or many direction, or some of these devices transmitted in one direction, specific direction. However, that's not your study for now. You need a device to transmit the data, and you need multi-device to receive the data. So that one, we call it transceiver. Why transceiver? It can send the data and it can receive the data from the user. How is that? You need to send the data. Okay, no problem. This is the AP, and the AP send me the data. No problem. I receive my data here in my computer. Now it's okay. Now I want to send a data myself. So here it is. I will send a data. So that device will receive my data. And that's what you usually do, by the way, when you actually using the router at home. The router at home send and receive, which is transceiver. The APs at any place you study in or you work in, that's the device. You need a transceiver device. That device usually work with specific frequency, which is different away, different type of frequencies. You may study that in wireless if you like to. However, for now, the radio technology or the radio wave, multi-radio technology in the market, which is include the AM, the FM, the cellular phones, the Bluetooth, the satellite, many things. Let's go over a few of them quick, just only as a basic information. You may have seen that somewhere in the city around you or in the highway. What's that exactly? This is the microwave radio. However, this is not the telephone or the mobile radio. This is microwave radio. So that one is not used for the cellular phone, for example. It's not. That's microwave. Anyway, companies, they use that. Different companies, they use that. However, it's very fast. They use micro wavelength, which is very short wavelength. There is no cable. It has a lot of advantage, by the way. However, it has one of the main issues, which is what we call it line of sight. What's that exactly? You have a tower here like this, and you want to send the data to that place in here. What we require, line of sight, which means that those devices, they have to not to see each other. However, there is no obstacle can stop the data here. So those devices or those towers, when you install them, those ones, they have to have no obstacle between both of them. How that? Sometimes you install up to 50 mile, something around 70K. So each one can cover up to 70K, sometimes more than that. Yes, but there is an issue as well with that when you try to put the line of sight, which is the earth curvature, which is, you understand that the earth curve like that. So when you try to send the data from here to here, you need to do some measurements, exact, precise measurement, so you can avoid that kind of curvature. Is that a good one? Yes. There is no wire, as you can see. It's easy to be installed, by the way, just a tower, and you can install something like that in few days, in couple days, if you have professional company. The cost is not much cost. However, it has a disadvantage as well. The disadvantage is it's being affected by the weather. The first thing, you cannot put any obstacle in the middle, which means that you cannot build anything to block that. Second, it being affected by the weather. So if you have thunderstorm, if you have heavy rain, if you have snow, whatever, it affected. And the most important ones as well, we have what we call it, you're familiar with something called reflection, which is the data over here hit something, reflected to the other side. For example, you hit something here, reflect here, which is okay. But we have something else called refraction, and that's one thing. For example, you have, this is the, just let me give you a very easy example. This is the water. This is water. When you have a signal which comes from air and hit the water, for example, what you think will happen to that signal? It will break down. Instead of here, it will be affected like here. So instead of going straight like that, it will not. It's gonna go this way, all breaking down little bit. You can actually see that if you have a glass of water and that glass of water has water like this, try to put anything over here, you will find that it become like that. What is that exactly? Refraction. When the frequency or when the signal pass from one medium to another medium. One medium means like one material. So from air to water, from air to oil, from whatever to air, from one device which made of material to another device which made of another material, different materials, and so on and so on. The satellite communication, we have the satellite really, it's orbit the Earth, not just in the 280 mile from Earth. No, it's not. It's not just like that. It's actually, we have satellite in different attitude or altitude. So it's like the highest, the distance from Earth. So you have satellite closer to the Earth, however it's outside the Earth, or what they call stratosphere. And you have another one take longer distance from that, another one longer distance, and so on and so on. So what I'm trying to say exactly is they are not all at distance of 280 miles from Earth, different distance, and for different reasons. What's the good thing with the satellite? You send the satellite, it's orbit the Earth, it can cover the whole Earth. Actually, it can cover the whole Earth and outside the Earth as well. Is that good? Yes. Is that bad as well? Yes. Some disadvantage it is. One of the main advantage is it's expensive. That's the main reason. Expensive. Require stations on ground, and if you don't have station on ground, you need to have portable, very expensive devices, and we have phones which work with satellite. By the way, you can Google that for how much you pay if you want one of those phones to work with satellite. Also, it affected by the weather as usual, and the dust, the thunderstorm, the electromagnetic wave, it's been affected. The signal or the data which you carry very small, very little compared to fiber optic, for example, compared to the Ethernet. So when we're dealing with satellite, usually we're dealing with kilobytes, megabyte maximum, but I never heard about anything beyond that. When you select a medium, if you've been hired in company and you want to select a medium, sure, you need to figure out what you actually planning for. You planning for LAN or WAN or MAN or what exactly? The backbone, we will come to it in chapter 7 or 8. But for now, do you want LAN, MAN, WAN? Because each one will have different type of cables. And we will cover specifically the LAN one. But in WAN, you may need the help of the ISP. Cost, they should put this at the top, by the way. We should use that at the top because usually the cost is the main factor. Mostly, in most cases, cost is the highest factor. And the cost usually depending on the distance. Because, for example, if I'm using a network and I'm building backbone network, I recommend to use a fiber optic, for example, cable. That's expensive. If you are using WAN, for example, so I'm gonna use the ISP, and that's when you need to purchase a T1 cable or different. The transmission distance as well, how far? So because, like, for example, the twisted cable which we saw you a few minutes ago, that one we have different type of those cables, which is Cat 5, 6, 7, the latest one in the market, 7. So however, those cables, the maximum distance, the width distance we can implement without implementing repeaters, 100 meter in most cases. What do you mean by 100 meter? So you can run the cable 100 meter without need to repeat so the signal, another device. Why is that? What about if you put it more than 100 meter? The signal will become weaker, will start getting weaker, and you will start having problem with your network. So you need to make sure that you need to decide how the distance is, the transmission distance. Sure, if you have a high campus, for example, if you have a big campus for the university, what's the best option to do with that campus? I can link it with wireless. One of the type of wireless technology, instead of building an Ethernet, for example. Yeah, I may use fiber optic if you want to afford that, but one of the good thing is you can cover the whole thing by wireless technology. Security, if you work in, for example, in government secure area, whatever, or department, wireless is not the best option. If you want top security, wireless is not the best option. Wireless always have problems with security, and that's another story. Error rates. Can you accept error rate? Can you accept errors? And how many errors you can accept? For example, 5 in a million, 2 in a million, 20 in a million. That's you need to accept. You need to figure it out, because the lower error rate you ask for, you need to pay more money for that. You need to spend more money for that, invest more money for that. Why is that? Because the error usually happen by the interference. Sure, yes, we have errors happen by the wrong design or the wrong implementation. But mostly when you have error, usually become coming from an external interference. So which means that something noise, what we call it noise. If you have, like if you talk in the walkie-talkie, for example, and you can hear some noise at the back, that's from the noise interference, radio frequency interference. And that's happened by many things. I believe that some of you may be familiar with, if you are home and you try to use the wireless and you have a microwave, for example, and you try to use the microwave, and that microwave close to the router, and you actually don't work, whatever, you will find that sometimes it terminate your connection. Sometimes. However, it will affect your connection regardless. The transmission speed, what do you want? Do you want something like DSL, for example, which is can give you like 10 meg, 15 meg? Or do you want DSL or ADSL? Or you want coaxial cable, which is can give you up to 100 meg or something? Or you want something very high speed like fiber optic, which can give you gigs? This is comparison between the medium and which one is good, which one is high, which one is the speed, and just comparison between each one. If you would want to transmit data, this data you have digital data, which is 0, 0, 1, 0, 1, 0, 1, 1, 1, like this. Okay, this one I can transmit it in two different ways. Using analog or using decoder or codes. What exactly that? If I want to use to transmit that into signal, I just need a modem. And that's what we have at home, by the way, computer. But if I want to use a digital transmission as well, so I want to get something which is transmitted in terms of 0, 1, 0, 1, 0, 1 as well. So digital transmission for digital data. I have a digital data and I want to send that. You can use different type. However, you need to have what we call it like the coder, encoder, decoder. You need to have equalizer, for example, what's quantization to do that, which is away from your study totally. And you can use different type of technology from the fiber optic, for example. You can use wireless, you can use wired, many things you can use it. However, you need something to make sure that not the modem, but you need something to encode and decode. What kind of transmission mode we use? Either serial or parallel. When we use the serial usually single wire, and you send the data like 0, 1, 0, 1, 0, whatever it is, one at a time and one after one, like this, for example, like that. If you want to send something like this is serial. Serial means 0, 1, 0, 1, whatever the data is being sent like that in terms of 1 bit at a time. 1 bit, 1 bit, 1 bit, one after one after one. And this one you can send it over a long distance. And this is, by the way, the most used when we building WAN. And that's why you see the link between the WANs, usually either kilobits or kilobytes at max. You send them bit by bit. The parallel mode, which is the one we use, usually use multi of 8 bits. It's actually multi of 7 bits, but there is 1 bit as error, or what we call parity error detection or error correction. Parity bit. So it's actually 8 bits a time, like that. You may have seen cables like that, maybe, especially the old cables. But when you send something like that, unfortunately, this one has a short distance. So it can come to up to 6 meters long, and actually up to, but less than that. In reality, it can be less than that, less than 6 meters in real. So either you transmit like that, 8 per 8, or you transmit as serial, and that's the most used, especially when we connecting when using old technology. I'm not gonna say the new technology, but the old technology before the fiber optic and the ADSL. How to do, that's the analog transmission of digital data. This is the example which I explained to you. When you are home, for example, and you want to send the data through the phone line, what you need to do exactly, you need to have a modem, and that modem usually take the data as a 0101 computer language into phone language. The phone language is analog. That analog usually goes to the TCO, and that's the teleco office, which is usually at the corner of each street, and then after that it been sent through the cables. There is multi-type of encoding the data. How you send data through the analog. How you send data, digital data. If I want to send digital data, I have 010101, whatever it is. That's I am sitting in my computer. I want to send the data from here to, I'm sending my data from my computer. I want to send the data. Here is the modem. The modem will take it, and here is the analog. Now this is the analog. Okay, and this is what I wanted to understand. Here is 01011101, like this, coming from the computer to the modem, and the modem has the other side over here, the phone line, which is signal like that. Alright, so usually the signal on the cable, it become equal signal like that. In short, the signal has the same height, the same width, and everything. Okay, now we need to modify that to carry a digital data, which we use something called quantization. But for now, it's away from your study totally. What you need to do exactly, when you have the AM, or the amplitude modulation, this is the original signal. As you can see here, this is the original signal. For example, imagine this is the modem. This is the original signal which came out of the modem. Yes, yes. Now I want to put, or this is the carrier, let's say. That's the carrier. And I want to put data inside that, 010101. The first thing to do, or the first type of modulation, we call it that the amplitude modulation, or the highest modulation. So the signal, as you can see over here, that's the signal. Can you see the number of cycle or hertz? The number of cycle here, can you see that? 1, 2, 1, 2, 1 2 like this. What's that exactly? The number of cycle, which we call it hertz, per time, whatever the time, if per second or per millisecond or per nanosecond, whatever it is, time units. So we have over here, that's the highest of the signal or the amplitude of the signal. We will modify the amplitude, but we will not teach the number of cycle. So I will modify the highest. Every time I want to send a digit 1, I will modify the highest. As you can see here, only the highest change when we have 1. What about the number of cycle? Is not, still as it is. So modifying the highest of the height of the wave, that's we call it the amplitude modulation. So only touch or modify ups and downs. In short, the data goes like this. Watch this. You want, I'm gonna send something like this, I'm sending like that. You said that I want send one. Oh, you want send one, here it is. I want to send another one. Okay, I want send 0. Okay, 0, it's come back here as normal like this. So when it become 1, you go high. When it becomes 0, back to normal. However, the number of cycle per time unit is still the same. What we call that AM, and all the radio stations, AM station, based on that. What is the other one? The other way around. The other way around, the FM, and that's the same thing, which is, what is that exactly? We will not touch the heights. So as you can see here, watch. All the signal has the same height. There is no different heights. So what is the difference? The number of cycle. So over here I have 1 cycle per time unit. 1 cycle per time unit. Really, yes. When it comes to 1, 2, 3, 2, 3, whatever it is. So here, this is, as you can see here, this is 1200 hertz, 1 cycle. When you try to send 1, I have to use 2, which means that I have to use 2 cycles of that. That's how it is? Yes. So here, what I am modulating the frequency or the number of cycle per time unit. The other way around from the AM. The phase modulation, which is maybe you came close to, maybe not, but the phase modulation based on this. Let me show you. You invert or reverse 180 degree of the wave when you have to send 1. Okay? So if you sending 0, keep going as you are. However, every time you try to send a 1, here it is, this is 0, 0, and everything more going smoothly like this. Keep going, keep going. Oh, here I felt that, I touched that, the signal, I'm gonna send 1. As soon as you feel here that you want to send 1, no, instead of going this way and continuing your work like this, no. Cancel that and invert in the other way around, 180 degree, and start the signal again. Until you finish, you stop here, you keep going like that. When you are here, invert again. Every time you try to send 1, you invert 180 degree to the other side. Up to here, we cover mostly what we need to cover about the physical layer. Now we will move to the data link layer, which is the layer number 2, and the normal switch, which is 2960 and 29 50, the one you will work on, that's the one you work on in Packet Tracer. That's the most used, and that's the one we call it layer 2 switch. As I mentioned to you before, we have something called layer 3 switch, which is a switch and router at the same time. So what's the main thing the functions and the services which layer 2 provide us? It provides us what we call it media access control. And that's one, the concept of that is you have an AP here in your place. And that AP, we have here me and my students here as well, and all of us, we want to access that AP. Okay, we want to send the data or receive data or use that. How that AP will control us? How will reply back to us? Who will start first and second and third? Is this like random or non-random? That's what we call it media access control. For example, another example, if you still remember the example I gave you at the beginning, this is the line bus topology or the multi-point. You have devices here. Okay, we want to use that link or the cable. Who will use it? Who will control that? Who's responsible for that? That layer. Another function, which is the error control. The error detection or prevention. Error detection, correction, and prevention. 3 of them. That's one of the top function, by the way. We have another the transmission, 2 type of transmission, and you will see that the asynchronous and synchronous. So the main function for the data link layer, remember those ones, the media access control, the error control, the data link protocol as well. At that layer, you can put devices as switch, bridge. We have something called bridge. And this layer, actually, by the way, later on it been break down into 2 different layers like that. This one become MAC and this one become LLC in a different project. But for now, that's how it is. Remember that one. So what's the data link responsible for? Moving message from one device to another. Although this is like not 100% covering the whole concept, but for the sake of that unit only as a business student, it's okay. What is the function for that? The media control, the error control, the message delineation. The message delineation means that you have a send a message, okay? I'm not sure exactly if you have used Wireshark as a software before or not. However, when you send the data, usually the data, if it's more than 1500 bytes, it breaks down into different. If you have, for example, 20 meg and you want a file with 20 meg and you want to send it away, that file has to be break down at 1.5 meg each, almost. Well, that's how it is. So 1.5, 1.5, 1.5, 1 point, like this, and been sent. How we know that this is the beginning and this is the end? Where is the beginning? Where is the end? That's the layer which is responsible for that as well. The media access control, as we cover in the multi-point. The multi-point, we have something called inside, if you study any of the topology, the network topology, this is what we call the ring topology. Ring topology, you have something like a medium like that and devices linked to that. Device, here, computer, whatever it is. And we're using, who actually can use that? One of us at the time. And if you send the data, you send it either in one direction like this, and when it's come like that, you have to wait until your turn come back. Who can control that? Who will use that link? How I know that, for example, I'm using that link right now. This user, how he knows that someone using the link right now and you cannot do anything? That's MAC, that layer which is responsible for the media access control, which means that it works as, you say something like the traffic light. So to give you green, so you can use, or to give you red, you can stop. That's, imagine that in very simple and basic concept. We can, or the system can, you can actually access the medium if you, one of them, which you want to avoid contentions, which means that if you want using the data loss and you go back again and again to do that, you don't want to do that, yes, so you can use another one which is controlled. The controlled means the wireless. Controlled, mostly wireless. The contention based, which means you need to accept collisions. Contention based, you need to accept some collisions. So that one may send the data, that one as well, collision, okay, so you have to send the data to this one to let him know that your data has been collide with someone else. He has to send the data again, and all those they have to wait. If you want something, why is that? Because not controlled. But if you want something controlled, the wireless, the AP, if you have used the AP for you, for example, at your home or the college or the uni, believe it or not, that AP has some kind of control. And when you access the data, for example, here, device number 1, you are here in the lab and you want to access all those students, they want to access the AP. Believe it or not, if you study the wireless, you will understand that the AP put you in queue. Put you in queue. And actually, before you send the data as you do, you need to request sending data to the AP first. Then the AP will reply back to you and put you on hold. How usually put you on hold, but we don't feel that. Yes, because all this communication done in nanosecond, not even millisecond, not microsecond, in nanosecond, something you cannot feel, but that's how it is, control based. The contention, which means that the data, whatever it is, transmit whenever the circuit is free. That's how it is. That's how it is. In short, as soon as I receive the data, I transmit, or I transmit whenever I want. That's how it is. If you want it in a very basic concept. If you have some people around that, for example, we want to send the data from here, here, like that. If you want to send the data and I want to send data as well, here, what we do exactly, it has to have collide. So as soon as I receive the data, I can send it, yes, but you need to accept that it has collisions. And we have statistics that when you use something like that, something around 50% of your data has to be, the performance, degraded by 50%. Control access, and that's the one which is we prefer. The AP has a unique way to do. If you don't use the AP, but you use wired one, wired still, but you actually want to control one, we have something, the token ring, for example, something like that, which I mentioned to you before. That's one, it's control as well, but it has disadvantage, a lot of disadvantage, and the performance is not high as you expect. And we have another way of something called request and polling. What's that exactly? You have a central unit like that, and that unit, for example, you have devices, device 1, device 2, device 3, device 4. Those devices, I want, what you do exactly, you put a flag, I want to send a data. You send the request to the central unit. Tell that central unit that I have a data I want to send. The data will the central unit will pull your data. You will not send the data. You will not be able to send the data. You actually sending a request, a special frame, a special type of data to the central unit, till the unit that I do have a data I want to send. That central unit will pull your data, but you will not be able yourself to send that data. You will not. The data link protocol or classification, if you want to send the data, two ways of sending the data under the data link, the asynchronous and the synchronous. Very easy and very concept. I just want you to be familiar with that. That one transmit character per character. This one transmit blocks, we call it frames. And this one can be up to 1500 bytes. That's the maximum for the normal networking system. So you can send up to 1500 bytes at once. Up to. Less than that, yes, but up to that. No more than that. For the normal network system. For the asynchronous, this one can send character per character, and usually the character we fit it in within 8 or 7 actually bits. If you have seen something called ASCII, just type in Google ASCII code and look at what is that exactly. You will understand that each letter in your keyboard has each letter or each number as well, or each key in reality in your keyboard has an equal number in term of binary, which means in term of 010101, whatever it is. Anyway, for the asynchronous transmission, what happened exactly, we have 8 bits, which is 1 byte. We reserve an error correction, error detection byte, which is byte number 8, and we take the first 7 bytes and we put the character we want in and we send it. That's how it is, yes. And as you can see here, to let the system, to let the medium knows that where is the start, where is the stop, here is the start and here is the stop. So this is the beginning, this is the end. The synchronous transmission, usually we use that a lot, by the way, and this one usually based on frames. The synchronous transmission protocol, if you want to categorize protocols, which is, I believe, that's a little bit away from your study, but just a very easy hint. The bit-oriented protocol, we classified it into 3 different types or categories. The bit-oriented, and this one, in short, a stream of bits. which based on bits in reality. This one byte count, which is, as it said, byte, but we call it character. We send the character per character. And byte oriented, and that one send the full bytes, which means that the eight bits. And this one, the example of that Ethernet, the example of this one, point-to-point protocol. And for this one, you just need a very basic concept about that. So the bit oriented, stream of bits, the byte character count, and the byte oriented, that's the full byte, or the PPP protocol. The 802.3, and this is the standards, or one of the standards which is an issue by IEEE. Actually, the fiber optic which we use, it has a standard as well, 802.3, which is Ethernet over fiber optic as well. It came. However, that's the most widely used all over. What exactly that? This is like the contention-based media access control, which means that 802.3, although it's really famous and the most used, still contention-based, which is collision-based as well. That's byte count, which is, here it is, the byte count, remember that, based on character count, and that's why we put Ethernet here. Error detection or error correction, that's optional. You can put that as an optional. And this is the last piece for today. What you can see over here, this is 2960 catalyst switch, which is the one you will work on in packet tracer a lot. This is the Ethernet cable or the Cat family, either Cat 5, which is, I believe, still in the market, Cat 6 mostly used, Cat 7, this is the latest. And there is one of the labs you need to actually, during the lab, you will compare between those ones in terms of speed, length, bandwidth, and everything. That connector, we call that connector RJ45 connector. The connector for the phone, RJ11. The phone connector is RJ11. The Ethernet connector, this one, RJ45. As you can see here, the network card, which is the NIC, we call it network card or network interface controller as well sometimes, but the most popular, the network card. That one can take multi shapes. So as you can see over here, you can use the port as Ethernet, or you can use the interface, let's call it interface, as coaxial, and both of them they will use as network card. No issue with that. As you can see here, this is the UTP cable or twisted, the Ethernet cable, and this is coaxial cable, and it can work very well. There's no problem at all. One thing I need to mention to you, that each network card built in something called MAC address. MAC address. What is that MAC? And by the way, that's a unique number, unique built-in number. When you hack someone, when we try to find out the hacker, we try to trace it through IP, and we try to trace it as well through the MAC address use, because that's, if we want to trace the PC or the device that hacker work, we try to trace the MAC address. Why is that? Because it's built in already, which means that in normal use you cannot change. However, we have a way to play with that, but away from your study. That's it's assume that you cannot change that the built-in MAC address. However, if you are a hacker, we have different way to go around that. What is the MAC address exactly? 48 bits, which is 6 bytes, 48 bits. The first 24, that's the name of the company manufacturer. The second 3 bytes, or the 24 bits, the other 24 bits, the serial number, whatever the number the company will put. Those ones usually issues by the IEEE to the company. For example, if you look at Cisco network card, you will find that number at the beginning, as you can see over here. Oh, the MAC address usually, let me show you number. If you try to, usually like this, A C colon 31 colon B, whatever, like this. So it's actually colon 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 like that. What is that exactly? That's the MAC address. You can go to that website. That website will give you, if you want, look up about any company. Or, by the way, if you have any MAC address, for example, just type ipconfig/all in your command line, ipconfig/all, and you will find a lot of data about your computer. One of it, the network card as well. Copy that, put it in something like that. It will give you the manufacturer of that company. I wish that was that much. Just try to go over the material, and I'll see you soon. All the best.